today I'm going to explain you slope and y-intercept. Slope and y-intercept we are going to identify in linear functions. So today basically you're going to learn how to identify the slope and the y-intercept in a specific linear function. And some functions we are going to isolate, so we are going to use the inverse operation. First, before to start with this topic, you have to identify what are the elements in the linear functions. Here we have the slope. The slope we are going to represent with the letter m, and the slope means or describe the slope of the line, or it's the change between the y-axis and the x-axis, or it's the motion. Now, the letter b, or it's the y-intercept, we are going to represent with the letter b, describe where the line crosses the y-axis, or it's we are going to have a specific graph and we are going to have a specific point, and for this point the line is going to pass. Now, the y and the x describe a specific point in the linear function, but today basically you are going to identify just the slope and the y-intercept, and in the next video you are going to graph these functions. First, you need to identify the slope. The slope we are going to represent with the letter m, and the y-intercept we are going to represent with the letter b. We have different type of slope. We have a specific 4. When it's positive is when the line increase. We have negative when the line decrease. We have 0 when it's horizontal, and undefined when it's vertical position, the line. Because when you graph the functions, you're gonna have different positions. Can be increasing, decreasing, can be horizontal, or can be undefined. So in this case, we are going to have just the value for the y-axis, or we are going to have just the value for the x in this case. So I have some examples here about linear functions. Remember, the functions is the form of the function, or it's like the formula, but it's not the formula. It's y equal mx plus b. So here we have y equals 2 over 3x minus 4. Remember, the slope you can represent with a fraction, or it's with a rational number. So the slope is, if you use the formula or the representation for linear functions, is this number, or it's the coefficient with x. So in this case the slope is going to be 2 over 3. So you are going to write what is the slope of this function is 2 over 3, and the y-intercept, remember, is the constant, or it's the last number or the number without variable. So in this case it's negative 4. So we have, for this function, we have 2 over 3 is the slope, and negative 4 is the y-intercept, or it's the constant. In the second example, we have negative 3x. Don't write negative 3x, just write the coefficient, or it's the negative 3. And in b, or it's the y-intercept, we have positive 1, so just write 1, or if you want to remember, write it positive 1. But in this, it's not necessary, because we already know that when we don't have sign, means that it's positive. In this one, we have y minus 5x equals 3. As you can identify, this is in a specific example. Why? Because always we need to have this function isolated by y. So in this case we are going to isolate, and in this case we are going to use the inverse operation. So we are going to copy y equal this negative 5x is negative, so we are going to move as a positive 5x using the transposition of term. So all the inverse operations is going to be 5x and the 3 positive 3. Remember, we don't change the sign in the positive 3 because we keep in the same place. Now we already have isolated this function, and we are going to identify the slope and the y-intercept. The slope in this case is gonna be 5, and you can add over 1 to write as a fraction. And in this one, for example, you can write it as a negative 3 over 1. It's important to have as a fraction because remember, the number or denominator means y and the denominator means x, or it's a the change in y and the change in x. So in this case, please write it when we have a whole number, write it as a fraction. And b, or it's a the y-intercept is going to be, here we have a positive 3, so just write it positive 3. The slope is 5 over 1 and the y-intercept is 3. In this one, as you can see, we don't have isolated, so we need to isolate for y. How are you going to do this? First, we copy 2y equal, and this is negative 4x, so we are going to move as a positive 4x. This is negative 6. We keep negative 6 because we don't use the inverse operation. We only copy in the same place. Now, in this case, we need to isolate by y, so we need to divide by 2 here. This one, you need to isolate by 2, and in this one, you need to divide by 2. So we are going to have 2 over 2 give us y equal 4 divided by 2, it's equals 2, and we copy the x. Now we have negative 6 divided by 2, it's going to be negative 3. In this case, you can divide as a whole number. Remember, the objective for this one is to divide, or to eliminate and to isolate the variable y as a 1. So remember, when we don't have number, that means 1y. So you can leave as a 1y or just y. Now, and then you have 4 over 2, that means 2x, and negative 6 divided by 2 give us negative 3. Now, the slope for this one is going to be 2 over 1, and the b is going to be equals to negative 3. Remember, we add 1 because it's you're gonna use this fraction to graph in this function. So in the next topic or in the next video, you're gonna learn how to graph functions, and you're gonna use this fraction. So always when we have only 5, for example, you add the number 1. Okay, so and remember, the slope is a number with x, so it's the coefficient of x, and the y-intercept is the constant, and sometimes you have to isolate using the inverse operation or isolating like this.